Hello everyone, myself Prasant. Today I am here with the new topic air sampling. So here we are going to discuss on the stages of air sampling, isokinetic sampling. So we start with the stages of air sampling. So in this there are different stages. We'll go in serial wise. So the first is we have to determine the objective. So the objective definition. So here we will determine the purpose of air sampling, such as assessing air quality, measuring pollutant concentration, or monitoring workplace exposure. This is like for what we are going to do the air sampling. Now the next is selection of sampling sites. So identify the locations that represent the areas of interest or potential exposure, considering factors like airflow patterns, proximity to emission sources, and potential human exposure. And the next is sampling time. So we'll determine the duration of the sampling. It could be continuous monitoring or grab sampling for a specific period. And the next is sampling frequency. So in this we'll decide how often samples will be collected, whether it's a daily basis, weekly basis, or monthly basis, like that. And based on these studies objectives and requirements, we'll define this uh, the frequency of the sampling. So the next is selection of the sampling equipment. Now equipment we are going to take, choosing the appropriate instruments and devices suitable for the type of pollutant or contaminants that we aim to measure. So the next is calibration and maintenance. Ensure that all sampling equipment is properly calibrated and maintained to obtain accurate and reliable data. So the sampling equipments, whichever we are going to take, that should be calibrated, they should be highly accurate. It's not like that the instrument is broken or not working properly, so it should not be there. So the next is safety precautions. So implement safety measures to protect personnel during sampling, especially if working in hazardous environments or dealing with toxic substances. So whenever we go for the sampling of air, it may be toxic, hazardous. So we have to be careful and take the safety precautions to protect ourselves. Now the next is documentation. So we'll have to maintain the detailed records of the sampling, that procedure, how we are going to do the sampling, and the location where we are going to do the sampling and all. The whatever equipment we are using and other relevant information of data interpretation and validation, like how at what time we collected, how much we have collected. So that should be maintained in the document. So now we will be talking about the isokinetic sampling. So you can see the picture of a cross-sectional view of a duct or stack. So inside this duct there is a sampling probe inserted to collect particles. So the probe has an inlet facing the gas flow and is equipped with an adjustable nozzle. The nozzle allows for the adjustment of the sample flow rate to match the gas velocity. So the probe has an inlet facing the gas flow. So that it will be facing towards the direction of the flow of the gas, and the nozzle will allow the adjustment of the sample flow rate of the gas velocity. So from this case we can see that the gas flow is deposited by arrow moving in the direction of flow, as we can see there in the sketch. The sampling probe is shown with its inlet aligned to capture a portion of the gas stream. The adjustable nozzle ensures that the sample rate is adjusted to be equal to the gas velocity, ensuring isokinetic condition. By maintaining the isokinetic conditions, We can ensure that the particulate sample collected is representative of the actual particulate concentration in the gas stream, allowing for accurate analysis and interpretation of the data. Thank you.